Google DeepMind just dropped Gemini Robotics and Gemini Robotics-ER, and let me tell you, these AI models are not playing around. We're talking robots that can adapt to situations they've never seen before, interact with their environment like a pro, and even perform tasks with human-level precision. Oh, and they can figure out how to slam dunk a basketball without ever having touched one. Yeah, it's that wild. Let's get into the video. Now, before we get into Gemini Robotics, let's talk a bit about the brains behind it. Google DeepMind. If you've been following AI advancements, you've probably heard of DeepMind. And if you haven't, they're the geniuses behind some of the most groundbreaking AI projects in recent history. Take AlphaGo, for example, the AI that made headlines in 2016 when it defeated Lee Sedol, one of the world's best players of Go, an ancient and incredibly complex board game. This was a milestone that showed machines could master tasks requiring intuition and creativity. Then came AlphaFold, DeepMind's revolutionary project that solved one of biology's biggest challenges, predicting protein structures. This breakthrough has accelerated research in medicine, drug discovery, and our understanding as well. DeepMind, which was founded in 2010 as an independent AI research company and was later acquired by Google in 2014. Since then, they've been at the forefront of AI innovation, tackling everything from gaming to healthcare. And now, they're setting their sights on robotics with Gemini Robotics, aiming to bring the same level of intelligence and adaptability to the physical world. So, what exactly is Gemini Robotics? They are calling it the Vision Language Action Model built on Google's flagship AI, Gemini 2.0. This means it combines three main capabilities: visual perception, language understanding, and physical action. At its core, Gemini Robotics is a multimodal AI system, meaning it can process and integrate data from multiple sources, like images, text, and sensor inputs, to make decisions and perform tasks. For example, if you show it a lunchbox and say, "Pack this," it can visually identify the objects, understand the instruction, and physically manipulate the items to complete the task. What sets Gemini Robotics apart is its ability to generalize. Unlike traditional robotic systems, this model can adapt to new scenarios it hasn't been explicitly trained on. This is achieved through some of the most advanced machine learning techniques, including transfer learning and self-supervised learning, which allow the model to apply knowledge from one context to another. Google DeepMind highlights three key areas where Gemini Robotics excels: Generality, Interactivity, and Dexterity. Let's cover them one by one. Generality refers to the system's ability to handle a wide range of tasks and environments, even those it hasn't encountered before. For instance, a robot trained to fold laundry might apply that knowledge to fold a different type of fabric or even a piece of paper. Next, interactivity focuses on the robot's ability to work alongside humans and respond to dynamic changes in its environment. This is powered by real-time perception and decision-making algorithms that allow the robot to adjust its actions on the fly. Finally, dexterity is about precision and control. Gemini Robotics uses advanced motion planning and control systems to perform delicate tasks, like removing a bottle cap or placing fragile objects without damage. These capabilities are underpinned by a combination of computer vision, natural language processing, and reinforcement learning, all integrated into a single, cohesive model. But how does it handle more complex reasoning, like understanding the intent behind a task or making judgment calls in uncertain situations? That's where Gemini Robotics-ER comes in, and trust me, it's even more impressive. Gemini Robotics-ER, short for embodied reasoning, where the system's technical sophistication truly shines. It is also built on the multimodal transformer architecture, which integrates the same unified framework as the other model. This allows the robot to process and interpret its environment in real time, much like a human would. Which means, when faced with a task like tying shoelaces, the system uses scene segmentation algorithms to identify the laces, their orientation, and the necessary steps to tie them. Then, it employs hierarchical task planning models to break down the task into subtasks, such as looping, pulling, and tightening. Its ability to generalize across tasks and environments is achieved through meta-learning techniques, where the system learns to adapt to new scenarios by leveraging knowledge from previous experiences. Say, if the robot has learned to fold a piece of paper into an origami crane, It can apply that knowledge to fold a different origami model it has never encountered before. This adaptability is further enhanced by self-supervised learning, where the robot improves its performance by continuously interacting with its environment and refining its models. As Carolina Parada, head of Google DeepMind's robotics division, explains, in order for AI to be useful and helpful to people in the physical realm, they have to demonstrate embodied reasoning, the human-like ability to comprehend and react to the world around us, as well as safely take action to get things done. Notably, companies like Boston Dynamics and Agility Robotics are already testing the models in real-world applications, from warehouse automation to household assistants, and the results are pushing the boundaries of what robots can achieve. Of course, with such advanced capabilities, safety is paramount. The company has developed a comprehensive safety framework to ensure that both models operate reliably and ethically. At the heart of this framework is the Robot Constitution, a set of ethical guidelines inspired by Isaac Asimov's famous laws of robotics. Technically, this is implemented through safety-critical reinforcement learning and risk assessment modules. These modules evaluate the potential consequences of every action in real time. To make it clear, if a robot is asked to pick up a fragile object near the edge of a table, it can calculate the risk of the object falling and decide whether to proceed or request human intervention. Additionally, DeepMind has included the Asimov benchmark, a standardized framework for evaluating the safety and ethical alignment of AI-powered robots. This benchmark tests a robot's ability to identify and avoid harmful actions, such as collisions, damage to objects, or unsafe interactions with humans. Under the hood, this is supported by formal verification methods, which mathematically prove that the robot's actions will not violate predefined safety constraints. Carolina Parada did emphasize, this framework would allow people to create, modify, and apply constitutions to develop robots that are safer and more aligned with human values. DeepMind goes further by employing a layered safety approach. If a robot detects an unexpected obstacle while performing a task, it can pause, reassess the situation, and either adjust its actions or alert a human operator. This multi-layered approach is critical as robots become more autonomous and integrated into complex, real-world scenarios. So, what does this mean for the real world? Well, Gemini Robotics could revolutionize industries like manufacturing, logistics, and even household automation. The possibilities are endless. And get this, these models can even figure out how to slam dunk a basketball without ever having seen one before. Isn't that the kind of adaptability we're talking about? Google DeepMind is already working with companies like Apptronik to build the next generation of humanoid robots. As we've mentioned, they're also giving trusted testers access to Gemini Robotics-ER, so we can expect even more advancements in the near future. As Carolina put it, we're very focused on building the intelligence that is going to be able to understand the physical world and act on it. And honestly, that's what makes this so exciting. So, what do you think? Are you ready to welcome robots into your daily life? If you enjoyed this video, don't forget to like, subscribe, and hit that bell for more tech deep dives. Thanks for watching, and I'll see you in the next one.